Hello, this is Itzel. Okay, quick replication of Tinman's coil setup. I've got this diagram, just painted it by hand. I have 12 volt battery, 10 to 10 ohm CSRs. I have a 2N3055 via 100 ohm driven by function generator. C1 is 330 microfarad. I have L1 is a small coil which I had laying around 2.7 millihenry and 2.6 ohms. C2 is also 330 microfarad. I have 4 LEDs, 3 watt LEDs in series, and I have D1 which is a UF4007. Function generator is battery powered, so I'm using 86 Hertz and duty 5% square wave, all DC, so not alternating. And I've hooked up my fluke meter for the battery voltage 12.35 at the moment, and this meter is having the average amps being drawn 15.9 milliamps at the moment. This is the circuit, 4 LEDs across the C2. This is my little coil, just one I had laying around, the transistor here. This is the 100 ohm base resistor, and I have here the two 10 ohm CSRs. I've hooked up my probes and the function generator here at the middle between the CSRs as a ground point, and I've hooked up my current probe in the Charlie 1 lead. I have the yellow probe across the input voltage. I have the purple probe across the CSR1 for the input current, and I have the blue probe across the CSR2 coming from the emitter of the transistor. And you will see that this signal is the same as what the current probe is picking up going to the C1 capacitor. Okay, signals here. If I calculate this voltage times average current, I have something like 196 milliamps, milliwatts, almost 200 milliwatts. And we can see that if I put up the mat, yellow is the voltage. I could not put the voltage down because I only have 4 possible measurements points at the side, so this is the 12.35 volts. Yellow and purple is the current across the CSR1, and I put also there the value in main, in average 15.4, which is similar as 15.9 or 8 with this little cheapo meter. I have the mat function up, the red trace, which calculate the yellow trace times the purple trace, and it comes out to a power of 186 milliwatts, which is very close to the calculated 196 there. So I'm fairly confident that this is the average power being drawn for the battery. Normally I put up as many cycles as can, and we can see that it still stays about the same 188 milliwatts input, but for clarity I will put it a little bit wider. The blue trace at the bottom and the green trace, blue trace is the CSR2, and it says something like 73 milliamps RMS, and green is the Charlie 1 current, which is around 66 milliamps RMS, but these signals are almost the same if we look at them. So this is according to me how you calculate the input. Just let the scope calculate the voltage and the current across the CSR, and then let it calculate as much cycles as possible, and you will have your 190 milliwatts input like I have at the moment. Okay, thank you for watching.